This is recorded video for non-homogeneous topic. I'm going to continue with the examples, okay, from the non-homogeneous topic, from problem 7, okay. Okay, we have done this non-homogeneous topic, okay, how we can solve, okay, until problem number 6. So here I'm going to continue with this problem number 7. Okay, so this is problem number 7. We have the questions on solve the differential equation. This is a given one. Okay, you can see that here on the right hand side of the equation in problem number 7, there is a trigo function in terms of sine. Okay, I'm going to write the ODE, okay, in the whiteboard here. Here we have the equation as 2d squared y dx squared plus 3 dy dx minus 5y equal to 6 sine 2x. Okay. See, we are going to start with the auxiliary equation. Okay. We have this auxiliary. On the left hand side, okay, we are going to write down as 2m squared plus 3m minus 5 equal to 0. Okay, then let's see what is the value from your calculator. We have A as 2, B as 3, C as negative 5. So the roots for M is 1, and negative 2.5. Okay, so these roots real number and different. Okay, real and different. And for the form of our auxiliary, okay, the complementary function, okay, will be written here. Real and different. AE something, okay, and then plus BE. So here we are going to write down YCS AE 1x, okay, plus BE negative 2.5x. Okay, so this is our complementary function. Okay, and second step, we refer to this YP on the right hand side. We have trigo function in terms of sine. Okay, then when we refer to the guideline, okay, when we have trigo function, let's see. Okay, we are going to refer to this D, part D. Okay, either we have sine or cosine, or we can have combination. Okay, we have these two different cases. Okay, whether we have straightforward or basic cases, or we have special case. Okay, or we call it as snake cases. Okay, these next cases, we look at whether are we having sine or cosine in the YC that we get just now. Okay, if there is sine or cosine in that YC, then we have snake case. Okay, so the YP will be this basic form. Otherwise, okay, we are going to use this case. Okay, when we refer back to our YC, okay, this is our YC. Okay, we have AEX plus BE negative 2.5x. There is no trigger function in this YC. Okay, so in this case, we have to consider the YP in terms of this case. Okay, we have this basic case. So we are going to write it down. Okay, so our YP will be, refer back here. Okay, A sine Px. P will be the constant, okay? Maybe we have sine 3x, sine 2x, okay, sine 4x, depends on our original equation. Okay, here we cannot use the same symbol for A, B, yeah? So you choose different notation because these A and B represent the constants, okay? So this time in A, the YP, we are going to use different symbols such as C and D. Okay, so the sine and cos px, when we refer to our equation just now, we have 2x, right? Okay, so we are going to use the same 2x. So, okay, so here I'm going to choose the notation as c, and then we have sine 2x plus d cos 2x. Okay, there's no issue. Maybe you wanted to use first one cos and then the other one in terms of sine, there's no issue. Okay, as long as make sure that there is no same symbol given for the constant. Okay, so this is our YP. This YP we got because our YC does not contain trigo. So we have a straightforward case here. Okay, so next what we are going to do, we are supposed to find the derivative. Okay, so we differentiate first derivative, differentiate this YP. Okay, we have, you can refer to the formula list if you don't remember. Okay, derivative. Okay, refer to this first column. Okay, derivative for sine we have cos. Derivative for cos will be negative sine. Okay, so here when we differentiate, we have 2c cos 2x. Okay, answers for this derivative. Okay, and the derivative for cos, we will get negative, negative sign. So here we have negative 2d sine 2x. Okay, so this is our first derivative. Okay, then we have second derivative. So you need to proceed another one. From the first derivative that we have previously, okay, continue to differentiate. Okay, derivative for cos here we get negative sign. So this will be times another 2. So we have negative 4c sine 2x. Derivative sign here we will get cos. Okay, then we have negative 4d cos 2x. Okay, and we are supposed to substitute our first and second derivative into the original equation. Okay, so second derivative we substitute here. First derivative we substitute here. Okay, this will be your YP. Okay, so this Y means your YP. Okay. Okay, I'm going to write down on the right here, right part here. So this side. Okay, we are going to substitute our dy dx here. Okay, and the second derivative here. Okay, then we have 2. Okay, multiply the second derivative. This is for sin. Okay, and then plus 3. First derivative is 2c cos 2x minus 2d sin 2x. Okay, minus 5. Okay, yp. What is the yp? So this yp. Okay, then put here times 5. The bracket c sin 2x. Plus d cos 2x. Okay, equal. So right hand side is 6 sin 2x. Okay, so I'm going to proceed at this part. Okay, we're supposed to open the bracket, so there will be constant times constant, yeah? Okay, so we just times out this one. Okay, then we have negative 8c. Okay, sin 2x. Then times this 2 and negative 4, then we have negative 8d cos 2x. Okay, then this times plus 6c cos 2x. Another 3 and negative 2d, then we have negative 6d sin 2x. Then minus 5c sin 2x minus 5d cos 2x equal to 6 sin 2x. Okay, next we are going to mark. Okay, sine with sine, cos with cos. Okay, so we have cos here. We have cos. Okay, and then we have cos. Okay, so the one that I underline it is in terms of cos. Okay, so basically you can write down here negative 8d cos 2x plus 6c cos 2x minus 5d cos 2x. Okay, so on the right hand side actually we don't have cos 2x. Okay, so it means that it is equal to 0. Okay, and in terms of sine, we are going to continue later on to find out what is the value of c and d. Okay, okay, in terms of sine, I will write down here negative 8c sin 2x minus 6d sin 2x minus 5c sin 2x, okay, equal to the right hand side 6 sin 2x. Okay, so we can write down this form, okay, such as negative 8c minus 6d minus 5c, okay, in the bracket, okay, sin 2x equal to 6 sin 2x. Okay, so this sin 2x equal to sin 2x. So the one in the bracket is equivalent to 6. Okay, we have one equation. Okay. This equation actually you can combine. So because we have C and C. So this equation can be simplified as negative 13C minus 6D equal to 6. Okay, so previously, the one that we got in terms of cost, okay, we can write down as negative 8D plus 6C minus 5D equal to 0. Okay. Okay, then we can combine for D. Okay, so we have 6C minus 13D equal to 0. Okay, we have equation 1, we have equation 2. Okay, the next step is to find out what is the value of constant C and D. Okay, so to get the value of constant C and D, we are supposed to apply either substitution method, okay, or elimination method. Okay, so the purpose is to get the solution. So if we want to use substitution method, okay, so you can express C or D from first equation. So you will get new equation and then express it in the equation number 2. Okay, if you want to use elimination method, okay, you have to make sure that equation 1 and 2 equivalent at some constant. Okay, for example, I can multiply, find the lowest common factor for this C. Okay, C is 6 and 13, right? Okay, so if I want to choose uh, C to be eliminated, okay, so this equation I will times 13. Okay, then the second equation I'm going to times with 6. Okay, find the lowest common multiple. Okay, so that is the reason why we times this equation by 13 and this equation by 6 with the objective to eliminate C. Okay, so if I multiply the whole equation of equation number 1, okay, with the constant, with the numbers 13, okay, so this will be new equation 78C, okay, minus 169D equal to 0. Okay, because 0 times 13 is 0. Okay, so this is the new equation. Equation 2, we are going to get negative 78C minus 36D equal to 36. So this is equation 3 and here is equation number 4. Okay, so we are going to proceed with this equation number 3 and 4. Okay, so if you want to eliminate C between this equation 3 and 4, we can just add equation 3. Okay, so we add equation 3 and equation number 4. Okay, why we are going to add? Because this is positive 78C, this is negative 78C. Okay, so to make it that C becomes 0, these two equation 3 and 4 will be added. Okay, so 78C plus negative 78C, we got 0C. Okay, and then we have negative 169D, okay, plus negative. Okay, plus and negative, there will be negative. Okay, then we have negative 205D equal to 36. Okay, because 0 plus 36 is 36. Okay, so our D will be negative 36 over 205. Okay, so what is your C? Okay, you can substitute in equation number 3 or 4. Okay, or you can substitute in equation number 1 or 2. Okay, does not matter. Okay, so let's say if I choose equation number 1. From equation number 1, I have 6c minus 13. So our D is negative 36 over 205 equal to 0. Okay, so we have 6c that is equal to okay, this number. Then we get C as negative 78 over 205. Okay, so it means that our YP is our YP. So C we get just now the number negative 78 over 205. Okay, sine 2x plus D. Okay, D is negative 36 over 205 cos 2x. Okay, this is our particular function. Okay, then the final step is to write down that our y as y equal to yc plus yp. So y as our yc is ae x plus be negative 2.5x plus a yp. Then you need to rationalize the sign. Okay. So this is the final answer. Okay. We are going to proceed the next example on problem number 8. Problem number 8 here. Okay, solve this ODE given. Then we have boundary condition here given. Okay, first one is this is the ODE. So I'm going to write down the equations here. Plus 16y equal to 10 cos 4x. Okay, this is the given equation. So step number 1, find out what is the auxiliary. We have m squared plus 16 equals 0. Okay, then when we refer to the calculator, we key in the quadratic. Okay. E is 1. Your B is 0. Your C is 16. Okay. We have the root as we have 0 plus and minus 4i. Okay, it's a complex root. Okay, now, when we refer to the auxiliary form, when we have complex root, so this is our YC. Okay, so generally, we are going to write down something like this form. have e to the power 0x. Okay. Then we have e cos beta x. Okay, beta is 4. Okay, plus b sine beta x. We have also 4. So e power 0 is actually 1, right? Okay, so can be simplified something like this. Okay, so we have reached at the complementary function. Okay, then we are looking at number 2. Okay, what is the particular function? Okay, yp, look at the right hand side. We have trigo. Okay, we have trigo, but then are we getting the straightforward case here, or we have snake case, which is a special case? Okay, now look at our YC, CF here YC. Are we getting the sine and or cosine appears? Okay, just now, yeah, we have trigo functions both in YC. So this is not straightforward case for YP, so there will be snake case. So this is snake case because our YC contain trigo, okay, in terms of sine and cosine. So your YP will be, okay, here. X, okay, time this brackets. Okay, so you be written something, Px. Okay, we use different symbol for the constant, so here's sine. C. Okay, cos for x plus the sine for x. Okay, so this is our YP. Okay, then find out the first derivative. Okay, because this is a product function, so take first part, differentiate the one in the bracket. Okay, we have negative for C, sine for X, plus 4D cos 4X, plus, okay, take the first bracket, differentiate in X, so we get 1. So here you're just having this form. Okay, so differentiate X is 1, so I'm not writing down the 1. Okay, and then proceed second derivative. Okay, there's another time to do the chain rule here. Okay, because we have first bracket and then second bracket. Okay, so take X, take first part, differentiate the one in the bracket. We have negative 16C. Okay, plus we take the bracket, this bracket, differentiate X, we get 1. See, then we have okay, so this is the form to differentiate here. Okay, we have another two parts that we are going to differentiate. This is just a direct differentiation, okay? So here we have minus for C sine for X. Then this one plus 4D cos for X. Okay. Okay, so we have done the second and first derivative, and then is to we're going to put here. Okay, basically we don't have first derivative. Okay, so it's actually only second derivative. So the second derivative just put here into our original equation. Okay, then plus 16y. This is actually a bit longer. Okay, let me write down again here. Okay, these two, we are going to simplify. Okay, let me show you this one. Let me combine. Okay, then here and here can also be combined. Okay, so negative 4c, negative 4c. So we have negative 8c. Okay, then 4d cos 4x combined with 4d cos 4x. 8d cos 4x. Okay, this is, since here, this one is in bracket. Again, then we have plus 16y. Okay, this is our y, yp. So I will just times out with the plus 16, plus 16 x. Okay, and c cos 4x plus d sine 4x equal to the right hand side is 10 cos 4x. Okay. Okay, now let's look at, is there any part that we can combine? Okay, let's when we open this bracket, this is actually x, right? Okay. So we got what? Negative 16 x. Okay, then we have c cos 4x, right? Okay, we have open bracket another time 16x d sine 4x. Okay, this remain the same thing, then nothing can be combined. Okay, now this one, open the brackets. 16x c cos 4x plus 16x d sine 4x. Sixteen x d sine 4x equal to 10 cos 4x. Okay, see this one. Okay, this negative 16xc. This one and this one, when we combine, it becomes 0. So we have negative 16x plus 16x. So it will be 0. And this one, negative 16xd. Okay. And this one, negative positive 16xd will be 0. Okay. Then we have to compare between cos and sine with sine. There is no sine on the right hand side. So here, when for sine expression, we have to write down something like this, negative 8c, okay, sine 4x equal to 0. Okay, because we don't have sine 4x on the right. Okay, then for d, we have 8d cos 4x would be compared with 10 cos 4x. Okay, cos and cos is this comparing it, left and the right hand side is equal. Then we have AD equal to 10. So D is 10 over 8 or 5 over 4. Okay, we have here C equal to 0. Okay, then we write down into, we substitute C and D value into our YP. Okay, so YP is X. Okay, C is 0. Okay, so this will be 0 plus D is 5 over 4 sine 4x. So this can be combined as 5 over 4x sine 4x. Okay, then one more. Y is YC plus YP. Then is YC here, A equals 4x. Okay, plus B sine 4x and then plus YP. Okay. So this is general solution. Okay, note that in the question just now, there's boundary condition given. Y3 divided x4, x0. Okay, so here you are supposed to proceed by finding the particular solution. Okay. Okay, so this is your general solution. Okay, so we use the boundary condition, your y3 divided x4 and x0 to find the particular solution. Okay. So this is our y. So general solution. So differentiate this general solution. Okay, so differentiate. This is your y. Differentiate this one. Everything here, okay, until the last one. We got as negative 4a sine 4x plus 4b cos. Okay, this is a special case to differentiate because we have x times sine 4x. Okay, first one, take the first part here. Differentiate sine. Okay, we have 4 cos 4x. And plus, take the second one, second part, differentiate this part. We have the constant only. And sine 4x. Okay. So this value, the boundary condition, okay, we substitute in general solution first, okay. Then we have as here. 3 equal to, okay, need to use a calculator, okay. Cos 4 times 0 is cos 0. Cos 0 is 1. Okay. 4 times 0 is 0. So cos 0 is 1. So A times 1 is A. Again, then sine 4 times 0, sine 0, it will be 0. So B times 0 is B. Okay, and then substitute here, sine 0 also 0. Okay, this part will be 0. So we have A equal to 3. So this is the first solution we get for A. And then we use this same boundary condition, okay, then we substitute into our dy dx. So dy dx is 4. Okay, this is second substitution. So 4 equal to, okay, sine 0, this part will be 0. Okay, then this is cos 4 times 0, cos 0. Then we have 4b. Okay, then there is a 0. There is also 0. Okay, here we have b is 1. Okay, then here we have arrived at the solution of a equal to 3, b is 1. And final answer for the particular solution. Okay, we have to write down what is a. A is 3. Then cos 4x. B is 1. Okay, then plus sine 4x. Plus 5 over 4x sine 4x. Okay, so we have reached at the particular solution. Okay, we proceed to problem number 9. Okay, so problem number 9 is here. So, okay, first I'm going to write down the equation first. Okay, we are going to start. Okay, this is second ODE. You can see on the right hand side. Okay, so number 1, start with the auxiliary. Fm squared plus m minus 6 equals 0. Okay, our A is 1. Our B is also 1. C is negative 6. Okay, so the root is 2 and negative 3. So this is real number and different. So YC, okay, is here. Okay, and then number 2. Find out what is our YP. Okay, so look at the YP here. This is trigo. But this is not trigo. This looks like our straight line equation, okay? This because this 12x, the degree at x is 1. Okay, so this is a linear equation, or we can say that this is a polynomial of degree 1. Okay, this is polynomial of degree 1. Degree 1 will be close or similar to straight line equation. Okay. Okay. In our polynomial, so we'll start with the polynomial. Okay. You are supposed to have combination of YP. Okay. So polynomial. Okay, we are going to use here, but we are going to use a plus bx. Okay. we don't use cx squared because this is the polynomial that we have just now. It's not in degree 2, it is degree 1. Okay, so we just use a plus bx. Okay, but I'm not going to use AB. I will choose different symbol. Huh? So our YP first, we write down YP for polynomial. So we say C plus DX. Okay, this is for polynomial. Okay, then for trigo, let's see. We have trigo and compare our YC. Are we having straightforward case or snake case? Okay, there's no trigo in this our YC, so it will be straightforward case. Okay, then trigo, this one. Okay, this is straightforward. Okay, just add. Plus. Okay, this one for trigo, I'm going to use different symbol. Let's say E. Okay. Sin x plus f cos x. For example, don't use same symbol like what we have previously for the polynomial. Okay, so then we proceed. Find the first derivative. Differentiate. Okay, C, D, E, F is a constant. Just definition is as a constant. Differentiate, here we have D. Okay, then we have E cos x minus F sin x. You can use capital letter or small letter, there's no problem. Okay. Okay, then second derivative. Okay, then here we have okay. Then we plug into our original equation. Okay. Okay, then we have this equation. Then we have minus 6y. So minus 6y, and we put here minus 6, and then this is yp. Okay, and then equal to right hand side. Okay. Okay, and we need to open this bracket first. Okay, let's look at is there any part that we can write down. Okay, we have negative E minus F sine x. Okay, and then another sign. See here. Minus 6A. Okay, negative E sin x minus F sin x, and then minus 6E sin x. Okay, then let's look at the cos. And negative F cos, and then we have plus E cos. Okay, this one cos. Then we have another cos minus 6F. x. Okay, then we have plus d minus 6c minus 6dx. Okay, then equal to 12x minus 50 sine x. Okay, we are going to compare sine with sine, cos with cos on the right hand side. Sine on the left will be compared to sine on the right hand side. Okay, cos on the left will be compared to cos on the right. We don't have cos on the right, so it will be equal to 0. Okay, we can compare something like this. This e and negative 1e and negative 6e can be combined. So we have in terms of negative 7e minus f. Okay, sine x. So it will be equal to negative 50 sine x. Okay, look. So I will just delete sine because we have compare sine with sine. So it will be equal to negative 50. Okay, the one in terms of cos, we can combine f here. Sorry, you can combine f here and this f. So you can have as e minus 7f equal to 0. Okay, then this expression okay, can compare this part and here. Okay, let us settle for this one. E and F. Okay, from the second equation, I can write down here as E equal to 7F. And then I put here. Okay, so negative 7. So what is our E? E is 7F. Minus F equal to negative 50. Okay, then we have negative 49F minus F equal to negative 50. Okay, then we have negative 50F equal to negative 50. So F is 1. So if F is 1, so your E is 7 times 1. So it will be equal to 7. Okay. Okay, so let's see. We're having this constant 1 and 7 in the solution. Okay, we have constants here. 1 and 7, but here we have different notation for the constant, but it is actually equivalent. It's just the symbol is a bit different. 1 and 7. Okay, let's proceed here. Let's compare this one. Okay, the one contain x. We compare with the one contain x. This one we will compare with 0 because we have 0 on the right hand side. Okay. Okay, so I can write down here negative 6d x equal to 12x. Okay, so x and x equivalent. So negative 6d is equal to 12. So d is negative 2. Okay, and then we have one more equation. So d minus 6c equal to the right hand side 0. Okay, but previously we have arrived at the solution of d. Okay, then can substitute here. Negative 2 minus 6c equal to 0. Okay, now we have negative 6c equal to 2. So c is negative 2 over 6, okay, or negative 1 over 3, equivalent value, okay. Okay, and then we have this value. All the constants that we have in the YP, we have getting the numbers. Okay, so you can compare, there's a constant negative 2 and negative 1 over 3, okay. Only the symbol for the notation is a bit different. Okay, and then final answer. Okay, so Y is YC plus YP. So what is your YC? Okay, we have AE 2X. Okay, so YP. Okay, YP is, we write down first, C plus DX plus E sin X plus F cos X. Okay, so Y is, this is YC. Okay, C, just now we have negative 1 over 3. Okay, we have minus 1 over 3. D is our negative 2. So we have minus 2x. So E is 7. 7 sin x. F is 1. Then plus cos x. Okay, so this is our general solution. Okay, so this is the explanation for problem 9. Okay. Okay, problem number 2. There will be the same thing, okay, except that we have the right hand side equal to product function, okay. So your YP will be times out also, will be multiply. Okay, so this is the step. I'm not going to write down for problem number 10, so I'm going to explain here. Okay, so first step, this is the auxiliary. Okay, so in the ebook, they use symbol of D. D refer to M, the one that I'm using in my explanation. Okay, so the auxiliary is given here, m squared minus 2m plus 2 equal to 0. And the roots we got will be in terms of complex number. Complex root. So this is your number and this j refer to your I. Okay, so the imaginary part is 1. Okay, and this is your YC. Okay, and then for YP, look at that. We have product. There's no addition or subtraction. Okay, because EX times cos 2X. Okay, so when we refer to the guideline, when we have product, so your function will be like this one, exponential and then the trigger. Okay, so your YP will be this exponential and trigger. Okay, so just proceed, but your combination for YP will be in terms of product YP. And then find the first derivative, second derivative, okay? And then equating the left hand side equal to the right hand side. Okay, so just comparing. And then you'll be getting the constant, what constant that you use in that YP. And then don't forget to write down again the general solution. Okay, so there will be similar step. Since in the equation of problem number 9, the boundary condition is given. So after you find out what is the general solution, you need to proceed, okay, by substituting this value. X0, Y2 divided x equal to 3, okay. So final answer, you must have constants value for all constant symbols. Okay, so hope that you can try Okay, with the exercise. So the tutorial for this subtopics will be updated in the WhatsApp group. Okay, so thank you for watching the recorded